Okay, so hello again. We are now in the third installment of Cyber Defender's Malware Traffic Analysis 3, Part 3. So again, still Brad Dancon. So there's a pcap that you need to download in order to begin the investigation. And of course, there's the setup guide. So it's very important to follow this, and it's also very important to update your Suricata role in the Brim so that you could be able to answer the succeeding questions, especially related to Suricata signatures. Okay, once that's done, we can now begin. So, of course, you have to open now the pcap in the Brim. Okay, for the first question, what is the IP address of the infected VM host? So again, we go to the Brim and search. Typically, we need to look on the Suricata alerts by source, destination, and notice here. Okay, what private IP seems to have the most detection? Okay, this is already a clue here. We have here the 192.168.137.62 having a Trojan detection. Then somewhere down, there's a bad traffic, of course, due to the Trojan. Again, still the same private IP. And notice here, it's the most rampant IP that has detections here, all the way down, even up to the exploit kit. Okay, as for the next question, what is the exploit kit name? So for this one, again in this view, we can go and pivot to the exploit kit activity detected. So pivot to logs. Okay, and you can see this is the name of that signature. It's PHP EKGate with HTTP post. So I tried PHP EK or EKGate because it's a two-word, but none seems to work. So what I did is search the signature, the Google. Notice here we have given another keyword here, Angular EK. So or even below, Angular exploit kit. So so I tried the Angular EK and that is the answer. Okay, so Angular EK. There you go. Okay, so number three, what is the FQDN that delivered the exploit kit? So if you recall, the number two, the exploit kit name is Angular EK. So we had to know more about this. So Googling remember in the previous question, we Googled it. So checking the references, what the exploit kit is all about. So we can see that this Angular EK is related more to a flash. As you can see here, okay, it's considered a flash exploit. So we are to expect to see flash MIME type on the delivered files. So we could actually go back to Brim and okay, you could go back to Brim and do a activity overview, pivot to file logs. So these are the files, and we can actually sort the MIME type. And we're interested into the flash MIME type, which is related to this one, related to the Angular EK exploit. So we have two here. We have two, and as you can see, we have two possible IP. Okay, 192.199, 198.58. So we could actually, since we're looking for the FQDN, what you can do is, okay, let's screenshot that. Okay, we have two related IPs, and then we are gonna pivot this and the HTTP request to check the FQDN. So, okay, we could actually search, oh, this one, let's try this. filter value. Okay, what happened? Oh, let's go back. Okay, let's go back to HTTP, and we're gonna filter the value of the rig age column. See there, and then we can replace it with the two IP related to flash, so 192.99.198.158. Okay, this is the first related IP that has a flash MIME type. Okay. Okay, why is there no results? Perhaps. Okay, so we just removed the other filter. So these are the FQDN for the first IP. And the other one is, okay, we can copy paste it. The other one is 93.114, 93.114.64.118. Okay, the other one, the FQDN is easysurgery.org or adstairs.co. Okay, those are the related FQDN. But the answer really is the first one, okay, which is the QWE. Okay, so the first IP is the answer. Okay, Number 4, what's the redirect URL that points to the exploit kit landing page? So remember, we found this. Okay, this is the FQDN that delivered the exploit kit. So we simply have to look for the referrer URL that points to this FQDN. So go back to Brim. Okay, remember this? Okay, actually let's go back to HTTP. Okay, and then we can actually pivot this FQDN. So recall this is found in the host. So for example, we'll filter this value. So replace it with the FQDN there. And then we just have to look at the FQUR referral link. And we will get this. So lifeinsidedetroit.com / blah blah blah. Okay? And that's the answer. Okay, what is the FQDN of the compromised website? Number 5. So again, go back to Brim. Okay, go back to Brim. HTTP. Pivot logs, and recall the compromised machine is this one, right? The victim machine. Okay, so let's investigate the HTTP connections, and you can actually notice here the referrer. Focus now on the referrer. So as you can see, okay, let's filter the compromised website. Okay, you can see, and if we'll focus on the referrer, notice which website domain has so much communications to our victim machine. So this one is seen multiple times, earsurgery.org, and that is actually the compromised website. And this is even the referrer, right, for the exploit kit domain. So yeah, so that is our answer for this one. Okay, number 6, which TCP stream shows the malware payload being delivered? Okay, we're going to find the stream number. Or recall the previous question, this is the FQDN that delivered the payload. So we are going to use this in a filter. Okay, so first, let's check the HTTP objects that can be exported by HTTP. And again, we'll use this FQDN. Aha. Okay, let's try that again. Okay, let's filter export objects, HTTP. Again, we're interested in this FQDN, specifically the application of the stream. So take note of the packet 2957. Okay, and once we have found the packet, so it's here. Right click and follow TCP stream. And actually, the stream that uh, related to the payload delivery is stream AT. Okay, notice this, the application of that stream. Okay, so that's the answer for this one. Okay, so number 7, what is the IP address of the CNC server? Okay, so for this, we can actually go back to Brim. Okay, Brim, and go to the ET alerts or by category. Okay, and let's filter for the network Trojan signature. And okay, pivot to logs. Notice here, we have two, we actually have 3 inbound traffic and 1 outbound. Okay, so of course, inbound traffic to the infected machine is more suspect, being a C2 traffic. So this is one is internal IP. So this leaves us to just one IP remaining, which is 209.126.97.209, which is actually the answer. Okay. And now what is the expiration date of the SSL certificate? So we could actually find that using Wireshark. Okay, as you can see here, I already filtered the C2 IP, and then you could actually just go to the transport layer security and simply drill down on the certificate info, and particularly the validity, not after value, which is the expiration value. In this case, it's November 24, 2024. Okay, which gives us this answer. So it's in DDMMYYYY format. Alright. Okay, going back, number 9, malicious domain serve as zip archive. What is the name of the DLL file included in the archive? So we're looking for a zip file. So first thing to do is go back to Brim, and then we could actually use this filter to filter zip files, packet containing zip files. And notice here, take note of the timestamp, the source, and destination. So this is the infected or the victim machine, remember? Oh, and this is the source that delivered the zip file. So go back to Wireshark and search for the related timestamp, the same timestamp, cross-correlate containing this source and destination. So we are dealing with 1827 50 135, 1827 50 50 135. So we're just dealing with this one. So this is the same timestamp and same source destination. Just around 3 packets in all. And okay, is that correct? Yes, it's correct. Okay. And the next one is 358. Wait, double check. 198158. Oh, sorry, this is not the correct. So this one is the correct one, right? 198.158, and then the destination is the victim machine. Okay, so notice here they both have all the packets. All the packets contain the same TCP payload, and it says reassembled uh, in frame 3728. So let's follow that frame. So we are now in the frame 3728. So the payload is reassembled here based from the previous packets we have observed or investigated. And notice here, okay, this packet seems to contain a lot. And notice here it even contained 339 lines. So we're probably looking at the right packet. So take note of the packet name, export. Uh, this probably contains the zip file, okay, that you are looking for. So now we're going to export it 3728. Okay, remember this domain that delivered the exploit. Okay, save this as zip file. Okay, let's save it into our downloads. Okay, save it at .zip. Save. Notice I already have that, so we just go replace. Okay, and then I'll show you. Since it's already in my downloads folder. Okay, this is actually the extracted. And notice it contains a DLL and a manifest. So this is actually the answer. Uh, okay, see? And when you search it or upload this DLL in the virus total, okay, this is a confirmed malware, right? Okay, number 10, extract the malware payload, deobfuscate it, and remove the shell code from the beginning. Okay, so we are already given a hint that it's quite a padded uh, file, and executable is embedded. So this should give you the actual payload DLL file used for the infection. What is the MD5 hash of the payload? Okay, so with this, we're going to go take a look at Wireshark again. Pcap. Okay, let's go back. So here in the pcap, recall in the previous question, we're going to export objects, HTTP. And recall the earlier question, this is the domain that delivered the exploit. And as for the related packet that contains the possibly contains the exploit, uh, typically we look at the application octet stream. So this is our suspect packet. So I have to save it. Okay, save it. Okay, save it in the downloads. Actually, I saved it already, so you will see that it will tell me it already exists. So we could replace, or okay, let's do replace. Let's go back. So now we have the file in our downloads folder. Okay, so we have here this one, but it's not really an executable. As you can see, it's a data file. So let's try to inspect strings. Oh, let's try to a hex dump. Hex dump 680. Sorry, hex editor. Let's try hex editor to see the hex or hex and the ASCII. Okay, if you will scroll down, okay, what can you notice? So it's like it's encoded or encrypted, no readable text. But what's interesting is that there is a repeated pattern here. Notice here ADR R2 B4N being repeated multiple times. And when you see something like this is a sign of encoding coding, right? In a way to in an attempt to obfuscate the code. Okay, so there's quite a lot. Okay, and again, we are dealing with Angular EK exploit here. If we Google it, Google Google Angular exploit, Angular EK exploit, and we can also uh, include the repeating pattern. Okay, let's go back. ADR2B4. ADR2B4. Okay, I think that will do. Okay. Okay, I think we have to include the whole. B4 NHA NH NH. Okay, and then the first related article really tells a lot. And we can see it's you can see here it's an XOR string key for the IE exploit, right? This is the same string. So that means we could probably, or most probably, decode this the code or the executable using this by XORing that file using this key. Okay, I hope you can follow. So we're going to do that using CyberChef. So CyberChef is a very handy tool. So to do that, okay, let's start from scratch. I'll show you from scratch. Oh, sorry. CyberChef. Okay, we could take that as an input file. This one, the one we downloaded from the pcap. So we can open this. Then we can do XOR. Okay, using the key. Okay, what's the key again? I think we can copy it from the search. So this is the key. But the thing here, we have to use UTF hex really to come up with the correct result. UTF-8. Okay. So as you can see, it becomes some strings are already readable here, right? Then we can now save this file. Okay, save this to a file. Okay. Okay, let me just remove because I've already done this previously. Okay, let's try to remove the existing files. Okay, so there'll be no conflict. Okay, save it. Okay, we save it as download.dat, and we're going to go back. Oh, sorry. Let's see. Okay, downloads. Can you see the download.dat there? See, it's still a data file. You can try hex editor. Okay, what can you notice now? Now we can see the MZ header, the magic number or magic string, right? Indicating that this is an executable. And the magic number 45A, magic string, indicating MZ. So meaning there's already an embedded executable here. But as you can see, there are additional paddings at the start. That's why it's not resolving. That's why the file type is not resolving as a PE executable. And with that, we will be using a tool called binwalk. Binwalk allows us to search for binaries embedded on a file or firmware. So very handy tool. So this is the command to use that. Okay, well, command to use that is binwalk space dash dash dd equals meaning we scrap everything, and then we're going to point it on the file that contains the embedded executable. In this case, download that, execute it, and if everything is okay, as you can see, was able to extract this file, which is an portable executable. Okay, this is a DLL we are looking for, so it will create a new extracted folder, as you can see here. Download that extracted. So, okay, and then we can check this file. There, it's actually a DLL. Then we can upload this in VirusTotal. So, okay, let's try that. Okay, choose file. See, it's already in the download extracted. Select that specific PE file, and as you can see, it's very malicious. So yeah, and this is actually our answer. Okay, it's quite a long process, but I hope you learned something. Okay, next, what were the two protection methods enabled during the compilation of the PE file? So here we will use again the winchecksec.exe. So you can download it from GitHub, this one. Okay, download the release for Windows, and once you have downloaded it, simply run this using this command winchecksec.exe, then the file. This is the DLL that we found earlier, and notice here it has isolation and SEH protection present. Okay, and isolation is also known as canary. Okay, so we won't go into details with that. We'll proceed with the other question. Okay. Okay. So for the other question, the next question. When was the DLL compiled? So remember, we look it up in VirusTotal. So just simply check the creation date, and it's in January 9, 2002. Okay. So that's the answer. Okay, 13. Okay, a flash file was used in conjunction with the direct URL. What URL was used to retrieve the flash file? Actually, in the hint before I answered it, the domain has actually started with A. So that's why it's a huge hint already. So all we have to do is go to Brim. And search for the activity with this MIME type, Shockwave Flash. Okay, and we actually have just two answers right here. And since the main hint or the answer format for the host starts with A, so this is actually our answer. Just have to write it in this format. Okay. Okay, 14. What is the CVE of the exploited vulnerability? So recall the exploit is Angler EK, right? And again, we searched it earlier in the previous questions, and we actually found this. Recall, this is the actual string in the extracted payload, and the actual CVE is this one. Okay. Okay, 15. What was the web browser version used by the infected host? Okay, we go back and we'll this time open the pcap using network miner. And recall, this is our infected PM, right? So infected IP 192.168.137.cc2. And under it you could actually see the host details and the browser user agent used. So this is the exact version, user agent string. And as you can see here, this is the Microsoft MSIE, Microsoft Internet Explorer, version 9.0. That's how we found this answer. Okay. Okay. Next, what is the DNS query that had highest RTT? Okay, go back. Let's inspect Brim. Okay, DNS events. So this is the actual query, and notice we sorted by RTT. Okay, response time, timeout. If I got it right. We can easily get this domain query ssl.gstatic.com. Okay, and last, what is the name of the SSL certificate issuer that appeared the most? So just one word. So here we will use Brim again. Here, focus on the SSL activities, and notice here sort issuer here, and we have sorted it actually, and just by inspecting it manually, eyeballing, this Google has the most number. Okay, that's how we got it. You can actually query it here, do a count, but since this is just 30 plus, so it's easy to eyeball this time around. Okay, well, congrats. See you on the next challenge.